Now, with walls and ceilings covered, you may notice that noise is still coming from somewhere. Very quickly, you may find that the vents are the problem. HVAC systems can transfer quite a lot of noise as they serve as conduits for sound from room to room. Now, there are specific ways to reduce noise being produced by the unit itself, but this section of the video is intended to address issues regarding ambient noise being transferred through the ductwork via room to room. Ducts are necessarily open pathway for sound because they must be open pathways for air. Because of this, solid barriers for sound isolation are not applicable. Sound absorption, then, is mandatory to remove sound from ductwork, with absorbing materials being placed where they can interact with the sound moving through the ducts. Porous materials placed directly within the duct is necessary where the duct is made of sheet metal. The materials should be placed so as to muffle sound without impeding airflow. Some companies sell mufflers to install in the ductwork, though I'm dubious to their performance. For example, car mufflers employ passive noise cancellation, which is tuned to the specific frequencies produced by the engine. However, this approach is not workable for residential soundproofing because of the sheer variety of frequencies that may need to be cancelled. So, duct soundproofing involves using, in general, sound absorption rather than cancellation at specific frequencies. The issue is you need a lot of absorptive material for it to work. Particularly in ducts used for heating, you need flame-retardant foam or fibrous materials. As far as fibrous materials go, Duct Board is an alternative, which is similar to the muffler shown previously, though the idea is for the entire network of ducting to be made of the duct board, which will ultimately give you a lot of absorption. You don't want to use typical unfaced mineral wool or fiberglass in the ducting because of the risk of loose fibers being blown into the living area and inhaled. If the duct is sheet metal and is not being replaced with any other type of material anytime soon, you can open up the ductwork and shove some duct board or foam such as melamine down into the duct as shown. The length of exposed foam/fiber material will help with high frequency, but also a bit with low frequency as well due to its length and distance from the sidewalls of the duct. You can also line the inside of the duct with an absorptive material or by pre-lined duct. The duct board mentioned previously is sort of like a pre-lined duct, and it is meant to be used in place of sheet metal ducting. That said, it is still preferable to use flex duct instead of any solid duct, as it will not transfer noise structurally half as well as solid duct will. If you have big problems with noise in the ducts, one of the best methods is the use of a baffle box. The box is lined on all inside faces with absorbent material and is divided with panels or baffles, which cause the air, and consequently the sound, to follow a circuitous path to the other side of the box opening, allowing much of the sound to be absorbed as it is made to bounce and pass through each bit of insulation multiple times. Because most of the absorption happens in the insulation and through expansion of the sound wave, the number of baffles should not take precedent over the total amount of space and insulation inside the box, particularly for low-frequency absorption. Baffle or isolation boxes can come in different designs and can either be lined on the interior with absorbent material directly exposed to the air, or can be made to accept flex duct snaked throughout it instead. Snaking the flex duct without the box is not as effective because most of the sound can go straight through the duct wall. My baffle box is installed inside of my bedroom rather than inside the wall or ceiling, though either of those placements will work. Pipes are a different issue. Sometimes the problem is the pipe banging around, and other times it is the sound of rushing water through a lightweight pipe such as a PVC drain. For banging pipes, first make sure that the pipes are securely fastened, as pipes that have excessive movement are more likely to break over time anyway, so the issue needs to be addressed regardless. Pipes can be fastened both resiliently and securely to reduce vibration while isolating them from the structure. This can be done by combining cheap, easily accessible closed-cell pipe foams and straps. For sound transferring through thin, light material such as metal or PVC, you would either replace the pipes with cast iron pipes or wrap them with a heavy, flexible wrap such as an MLV product or perhaps lead tape, especially if wrapped over pipe foam to create a small mass-air mass barrier as discussed in more detail here. Be sure to check local building codes for what is or isn't allowed.